Welcome back, everyone. In our short journey through AI, we've managed to cover a lot of ground. From the foundations of machine learning to the intricacies of deep learning, and most recently, we've explored the fascinating world of AI agents. We've seen how these intelligent systems are revolutionizing industries across the board. Today, we're taking an exciting leap forward. We're going to roll up our sleeves and learn how to build an AI agent from scratch. But this isn't just any AI agent. We're going to create an AI trading agent to analyze stock data and assist us in making crucial buy or sell decisions. Cool, right? To bring this agent to life, we'll be harnessing the power of the AWS technical stack. Specifically, we'll dive into two powerful tools, Amazon Bedrock and Amazon SageMaker. So, if you've been itching to see how AI concepts translate into practical applications, you're in for a treat. Because this tutorial is designed to bridge that gap between theory and real-world implementation. Now, a quick note before we start. While we're focusing on the AWS stack today, other cloud providers like Azure, Google, or Oracle offer comparable AI capabilities. So, the concepts we'll cover can be adapted to these platforms as well. Alright, enough preamble. It's time to turn theory into action. As mentioned, we're about to explore two powerful alternatives for building our AI agent. First, let's talk about Amazon SageMaker. This is a comprehensive managed service that covers the entire spectrum of machine learning model development. SageMaker provides an impressive array of features. It offers tools for every stage of the ML lifecycle, from preparing your data to deploying your finished model. It supports a wide range of ML frameworks and algorithms, giving you flexibility in your approach. SageMaker also includes automated model tuning and scaling capabilities, saving you time and effort. Finally, it integrates seamlessly with other AWS services for data storage and monitoring, creating a smooth workflow. Now, let's turn our attention to Amazon Bedrock. This is a fully managed service specifically designed for building generative AI applications. It leverages foundation models from both leading AI companies and Amazon itself. Bedrock brings several key advantages to the table. It provides a unified API, allowing you to access various pre-trained foundation models with ease. Its serverless infrastructure eliminates the need to manage compute resources, simplifying your operations. Bedrock also offers capabilities for customizing foundation models privately, using techniques like fine-tuning and retrieval-augmented generation. Lastly, it includes tools for creating AI agents capable of executing complex business tasks. Both these services offer powerful capabilities for building AI agents, each with its own strengths and focus areas. Let's discuss when to use each of these powerful tools. The choice between Amazon SageMaker and Amazon Bedrock depends on your specific needs and project requirements. Amazon SageMaker is your go-to solution when you need to build custom machine learning models from the ground up. It's ideal if you require granular control over the entire ML pipeline, from data preprocessing to model deployment. SageMaker shines in projects that involve complex data preprocessing and feature engineering. It's also the tool of choice when you need to train and deploy traditional ML models for tasks like regression or classification. On the other hand, Amazon Bedrock is your best bet when you need to quickly deploy generative AI applications. It's perfect if you want to leverage pre-trained foundation models without the hassle of managing infrastructure. Bedrock offers a serverless, API-based solution that's particularly well-suited for tasks like building chatbots, generating content, or performing text analysis. In essence, Bedrock excels at rapidly deploying generative AI using foundation models, while SageMaker provides the flexibility and control needed for custom ML model development and deployment. Your choice will depend on your project's specific requirements and your team's expertise. Let's now address a critical challenge for our AI agent. When using foundational models, whether through Bedrock or SageMaker, we face a peculiar limitation. These solutions rely on pre-trained data, which means their knowledge is essentially frozen at the time of their deployment. This obviously poses a problem for applications like stock trading, where up-to-the-minute information is crucial. Imagine trying to make trading decisions based on last year's stock prices. It simply wouldn't work. And so, our AI agent needs access to the most current data, including intraday historical stock prices, to make accurate prediction and guide effective trading decisions. So, how do we bridge this gap between the foundational model's static knowledge and the dynamic, real-time data we need? Well, this is where the concept of Retrieval-Augmented Generation, or RAG, comes into play. What is RAG? It's a technique that boosts a large language model's abilities by letting it tap into external sources, like knowledge bases or databases, before answering, making its responses more accurate and relevant with the latest info. Now, let's see how RAG can power an AI agent or application needing real-time data, like stock trading. First, external data integration. RAG adds a retrieval layer to pull in up-to-date info from APIs or cloud storage, like Amazon S3. For stock prices, you'd grab live data from APIs like Alpha Vantage and keep it fresh in an S3 bucket. Second, retrieval mechanism. When a user asks, "Should I buy this stock now?" RAG fetches the latest data, optimized with tools like Pinecone for fast, smart searches. Third, prompt augmentation. That data, like live prices or trends, gets added to the query, so the model has full context. Fourth, model response. The model then crafts an answer using both its training and that fresh data. Finally, continuous updates. To stay accurate, the external source gets refreshed constantly via automated pipelines or streaming APIs. Okay, let's discuss how we can build our agent using Amazon Bedrock. Let me assume that we already took care of creating an AWS account and granting to our user and role the needed permission to Bedrock, and that we also enabled the foundation models we want to use within Amazon Bedrock. So, to create an agent, navigate to the Amazon Bedrock Builder tools, head to the Agent view, and click Create Agent. Next, you'll need to equip your agent with clear instructions about its tasks and the tools it requires to act, drawing from a knowledge database. As mentioned, our agent needs clear instructions. To narrow down our use case, let's say that we want our agent to assist us with placing covered calls, and more specifically, with identifying the lowest strike price for a sell to open call expiring in 4 weeks, with the highest probability of never being assigned. Essentially, the agent should help us keep the premium from selling the call without having to sell our shares. To do this, our agent must first retrieve the latest stock price. So, we'll define an action group that accesses the Alpha Vantage API to fetch that real-time price. Next, the agent needs to determine the lowest strike price. For this, we'll create a second action group, giving it access to a specialized Lambda function that calculates this strike price and uploads the result to S3, updating our vector database. Finally, the agent can query our knowledge base for the result. Let's draw this out and see how our end-to-end architecture looks like, starting from our agent, with their instructions, action groups and knowledge base. To make it simple, we can create and schedule a simple script running on our local laptop and using AWS CLI to invoke our agent at the beginning of a trading session. Next, once invoked, our agent will work with the defined foundation model to determine the exact steps to perform. We just went through these steps in the previous slide. To summarize, our agent uses our first action group to retrieve the latest price of the desired stock, then requests our specialized Lambda function to calculate our pivotal trading indicators, before pushing the info into our knowledge database via sync with our OpenSearch instance. Our agent will then query OpenSearch to retrieve the strike price we should aim at. Finally, our agent sends to the selected foundation model both our default prompt, the agent's instructions, and the result retrieved from our knowledge database, so that the foundation model can formulate the final response. Let's go one step deeper and start where it all begins. First, we log to AWS console and update our IAM permission and role to have the needed access to Amazon Bedrock. It's a simple first step. Next is to create an S3 bucket, prepare our stock data, and upload it to S3. We can then create our knowledge database, OpenSearch, and sync it with our input data. Finally, we can implement our AI agent code and start testing it. Okay, let's first log in to our AWS account, and don't forget to enable MFA. Let's then navigate to Bedrock, and ensure we have access to all the foundation models by enabling them. Next, we need to create our S3 bucket, which will be used as input to our knowledge database. So, we navigate to S3 and we just follow the steps to create a standard bucket. We upload our initial stock price data file. Remember, as we invoke our AI agent, the agent will be updating this file with the latest price data. But we'll talk about that later. For now, let's go back to Amazon Bedrock. From here, the next step is to create our knowledge database. To make it simple, we'll proceed with the default settings. We'll source our vector database from our S3. We'll link our database with the data we uploaded in our S3 bucket. We'll use OpenSearch. And we'll select Amazon Titan Text Embedding as our model. And finally, we create our knowledge database. Well, since this process can last up to 10 minutes, take a well-deserved break. Okay, our knowledge database is now created. Let's sync our database with the data from our S3 bucket. We can now configure our RAG. Again, to make it simple, we'll use all the default settings. After all, we just want to check if our knowledge database has been properly created and configured. Let's now ask what our target price for a date that doesn't exist yet in our knowledge database, and see what the response is. As expected, we don't get much from our knowledge database. Okay, let's now ask the same question but for a date we know we have calculated the predicted target price of our favorite stock. And, here, magic, we get the response we wanted. Cool, right? Alright, this is it for this demo showing how to quickly create a knowledge database and enable RAG with Amazon Bedrock. Now, we can proceed by updating our AI agent code to retrieve the most recent data for our stock, calculate our target price, and provide us with the most appropriate answer for today's stock actions. But, let's not do that yet. Because, in the real world, while this solution works for many use cases, for performing complex predictive analysis, like trading stocks, using a pre-trained model isn't ideal. And so, let's talk about Amazon SageMaker. As mentioned earlier, Amazon SageMaker is a fully managed service designed to simplify the process of building, training, and deploying machine learning models. This means that as opposed to Amazon Bedrock, where we simply augment an existing pre-trained foundation model with our own data, with SageMaker, we can go one step further and build our own foundation model, train it, evaluate it, deploy it, and integrate it with other AWS services to attain our end goal. So, let me explain briefly how it could work with SageMaker. First, We collect raw data from various sources to use in our machine learning project. We can build Lambda functions to retrieve real-time stock price data and latest market news and store this data in Amazon S3. Next, the acquired data must be cleansed, transformed, and prepared so that they can be used to train our machine learning model. To do that, we can leverage EventBridge to trigger via an SQS to trigger a Python script that SageMaker processing runs to fill in any missing price values, normalize the prices and calculate the relevant technical indicators to make informed decisions, before saving the processed data back to S3. Next step is to transform this data into a format suitable for machine learning, often by creating features or embeddings that capture important patterns. SageMaker doesn't generate embeddings directly, but you can use SageMaker processing or SageMaker notebooks to perform this task. For example, we can use SageMaker processing to generate features from the stock data, such as the difference between consecutive prices or percentage changes. These features help the model understand trends and patterns in stock movements. Now, some data, like the latest news information, cannot be included directly into the foundation model as we discussed earlier, and instead, we can augment our foundation model implementing RAG and pushing our data to a knowledge database, like OpenSearch. Agreed. I may have jumped to the gun talking about RAG, since it's used at runtime before querying our model. And, as you probably notice, at this stage, we don't have a valid model yet. Indeed, our next step is to train a machine learning model on our processed data to make predictions or decisions. For instance, we can train a long short-term memory model using SageMaker's TensorFlow container to predict stock price movements based on the time series features created earlier. We can then evaluate our model by assessing how well our trained model performs on unseen data. We can leverage SageMaker Clarify for bias detection and SageMaker Model Monitor for performance tracking. You can also run evaluation jobs to compute metrics manually. For a classification model, calculate metrics like accuracy, how often the buy-sell prediction is correct, precision, and recall. And for a regression model predicting prices, like in our case, compute the mean squared error to measure prediction accuracy. Once we're satisfied with our model, we can deploy it to production. SageMaker offers deployment options like real-time endpoints for instant predictions, batch transform jobs for bulk predictions, and serverless inference for cost efficiency. In our stock trading case, we can deploy our stock recommendation model as a real-time endpoint in SageMaker, so that our AI agent can then send current stock data to this endpoint and receive an instant recommendation, buy or sell, based on the model's prediction. We can build a containerized Python application to fetch real-time stock data, pre-processes it, sends it to the SageMaker endpoint, and receives a prediction. Finally, our agent can apply a simple probability rule to recommend a buy, sell, or hold the stock. Pretty powerful, right? And there you have it. Let's quickly recap what we've accomplished. We discussed how to build an AI agent based on Amazon Bedrock and Amazon SageMaker. Agreed. We didn't dive deep into SageMaker capabilities to build, train and deploy our own foundation model, but we did accomplish what we wanted. We built an agent leveraging Amazon Bedrock. And while we could spend hours to further enhance our proof of concept, this simple project demonstrates the power of combining AI with cloud services to create sophisticated systems. And so, as you continue to explore generative AI and AI agents, consider expanding this simple project by integrating sentiment analysis from financial news. Last, remember, while AI can be a powerful tool in trading, it's crucial to approach it responsibly. Always thoroughly test your systems and never risk more than you can afford to lose. And, as always, if you found this tutorial helpful, please hit the like button and subscribe to our channel. Thank you for watching. Until next time, keep innovating and pushing the boundaries of what's possible with AI.